Step 2 is to enable multicast forwarding. We do have two set of commands. Number 1 is IP Multicast routing, which should be configured on the global configuration mode. And next thing is the IP PIM sparse mode or dense mode that should be configured on any interfaces or transit port or any loopback interfaces. So if we enable PIM, IGMP automatically gets enabled. Next is to verify the enabled interface or PIM and the multicast routing table. Note that this is a reserved group for a Cisco RP discovery and all runners join on this multicast group. This IGMP join signals that we want to receive a multicast traffic for a specific multicast group. Next is the restrict host connected to R1 G10 interface. From the output of IP Igmp interface, we can see that the access list that we've created name groups is already added on the inbound Igmp access group. This IP Igmp immediate lib group can be enabled globally or on a specific interface only. In our case, I'll be configuring this on a specific interface which is G1/0. So we need to create an access list which defines the multicast group. In this case, I'm allowing all class D addresses that affects all multicast group. I have enabled IP IGMP debugging on R2. Next thing is we need to disable the IGMP on R7 interface. After disabling the IGMP in R7, R2 received a leave group message from R7, and R2 immediately removes the specific group on its multicast routing table without sending a leave query message to all hosts under the specific group. From R2 debug output, we can see that it sent its first query to R7 under group 224.7.7.7. And the second query sent to R7 again. And after the second query, we can see that group 224.7.7 disappear on the IGMP group list. We can also change the default values for the last member query, which is by default is 2, and the interval of 1000 ms or 1 second. So we could change that. For example, the last member query count will be 3 and the interval will be 500 milliseconds. From R2 debug output, we can see that we sent 3 lib queries to R7 related to 224.7.7 multicast group. In addition, this being sent every 500 milliseconds. Next is we need to configure R2 such that the number of mroutes state created as a result of host membership report is maximum of 3. This policy only affects R2's interface G10. As you can see here, we only have 2 active groups. So let's create additional groups on R7. We can see from R2 that the maximum mroute has been reached. So we have 3 roles. Number 1 is PMDR, Igmp Querier, and IP Forwarder. From here, you can see that the multicast DR is R2 and the Igmp Querier is R1. Note that the DR is the device with the highest IP address on the subnet, whereas the Igmp Querier is the device with the lowest IP address. So from R1 and R2, we will configure the IP Igmp Querier to 90. Now from R2 and R1, we can see that the timeout is now set to 90 seconds. From here, you can see that we shut down the R1 interface G0. So the backs represent the LAN segment for the multicast group. And after 90 seconds, after shutting down the R1 G20, you can see that from R2, it has been elected as the DR, and it also elected as the Igmp Querier router. So if we re-enable back the G20 interface of R1, it will run a reelection between R1 and R2. So it will be based on the highest IP for the DR and the lowest IP address for the Igmp Querier router. We can also tune the maximum response time, in which by default is every 10 seconds. And we can set it to 25 seconds. This is related to the Igmp reporting or membership report that being sent out as Igmp join. So for test method number 1, we're going to use the Igmp join. So we're going to test the multicast address of 239.4.4.4. So let's conduct a network reachability test between R5 and R1. For test method number 1, we need to specify the RP address, which is R1 on all of the routers. Second is to configure the Igmp join on the receiver router, which is R2. Another method we can use is the MRM. So in order to configure the multicast routing monitor or MRM, we need to set the sender, the MRM receiver, and the MRM manager. So in this case, R5 will be the MRM test sender, R2 will be the MRM test receiver, and R3 will be the MRM manager. So we need to run the MRM process using the MRM command, plus we need to specify the MRM name, which is the Igmp-lab, and specify start. And as you can see here, we can see a multicast traffic being detected by the MRM manager. So we can see the sender and the receiver, and as well as the packet loss. One advantage of this using MRM is it can generate report and statistics.